Concurrent forces, example number 1, determine the resultant of the three forces. First step is to sum up the x component and y component. Sigma f of x is 10 cosine 45 minus 5 cosine 30. Minus siya kasi left x component pa left is negative and then pa right positive. Plus 15 cosine 60. And mag-i-equal siya ng 10.24 Newton. Sa f of y naman, sigma f of y 10 sine 45 plus 5 sine 30. Positive siya. Component of y pataas, positive, pababa, negative. Minus 15 sine 60. Nag-i-equal siya ng negative 3.42 Newton. Para naman sa resultant, ito yung equation niya. Square root of sigma f of x squared plus sigma f of y squared. And then 10.24 squared plus negative 3.42 squared. Then solve. Then magre-result siya ng 10.8 Newton. Para naman sa tan theta, ito yung equation niya. Tan is equals to sigma f of y over sigma f of x. Tan negative 3.42 Newton, and then f of x is 10.24 Newton. Na magre-result as negative 18.5. So yung sagot is resultant 10.8 Newton angle and negative 18.5 degrees. To determine the resultant of the 5 forces, 1, 2, 3, 4, 5. So, first step, sig x. Kunin mo na yung x component and y component. Same sa ginawa ng sample sa number 1. 180 cosine 0. Kasi tapat na siya sa x. 0. Negative minus 180 cosine 45. And then plus 160 cosine, bugtong ko na lang 45. And then plus 200 cosine 30. Mag-result siya ng 339.07. Sigma f of y is equals to, unahin tong y since tapat siya sa y. Sure. 240 sine 90 degrees. Nasa 90 siya. Next is negative 160 sine 45. And next, negative 200 sine 30. And then last, negative, pababa siya, 180. Negative 180 sine 45. Then nag-equal siya ng negative 100.42. Then sa resultant, same lang yung equation. Sig f of x squared plus f of y squared. F of x 339.07 squared plus negative 100.42 squared. Then result niya is 3537. Yan. Important. Contour yung equation is equals to
mamaya ko lang sana re-reply. Si Ate Emma, di ko ni-reply. Wait lang nga, may titignan ako.
sigma
Wait
f
lang
of
ha.
y and
Hanapin ko muna yung ano.
sigma f of x.
So, nalaman ba sa'yo?
Type dun sa calculator, shiftan.
Wait lang.
100. Negative 100.42. And then, positive 339.07. And mag-equal siya ng negative 16.5. So, yung sagot niya, resultant is equal to 353.7 angle. And theta is equal to negative 16.5 degree.
Okay, so in the first problem, let us determine the resultant of the 6 forces as shown in the figure. The first thing we're going to do is sum up the x components, which are 20 cos 25 minus 30 cos 45 minus 40 minus 50 cos 60 plus 7 cos 30, which results to sigma fx is equal to negative 7.465 Newton. And next, let's sum up the y components, which are 20 sine 25 plus 30 sine 45 minus 50 sine 60 minus 60 minus 70 sine 30 equals to negative 108.635 Newton. So what we have here are the sigma fx and sigma fy, which are actually x and y components of the resultant, or the equivalent or the equivalent force. And to find this magnitude, what we need to do is square them, add them, and take under the root. So, ang makukuha natin is 108.89 Newton. And if you want to get the angle of inclination, ang gagawin natin is sigma fy divided by sigma fx, and ang magiging sagot is tan theta. You take the tan inverse and you will get angle, which in this case is 86.07 degrees. So, pag pinagsama-sama natin yung figures, ganito yung kalalabasan niya. 108.89 at 86.07 degrees in the third quadrant. So, bakit siya nasa third quadrant? Because sigma Fy and sigma Fx are both negative, and the angle sigma Fy upon sigma Fx and yung theta na nakuha natin ay nasa x-axis. So at this point is either you apply the 6 forces or apply the single force or yung resultant natin, which are 108.89 Newton and 86.07 degree. Okay, so next example, we are going to determine the resultant of 3 forces acting on the hook as shown in the figure. So, same method. Sigma Fx is equals to, kukunin natin yung x component. So, 80 cos 25 plus 70 cos 50 plus 50 cos 45. So, i-add lang natin and ang magiging sagot is 152.855 Newton. Tapos, kukunin naman natin yung y component. So, sigma Fy is equals to 80 sin 25 plus 70 sin 50 minus 50 sin 45 equals to 52.077 Newton. So, nakuha natin yung sigma Fx and sigma Fy, yung dalawang components, yung sagot dun sa dalawang components natin. Tapos, i-add lang natin yung component x and component y, and then hanapin natin yung angle. So, ang answer is 161.48 Newton at 18.8 degree with x-axis in the first quadrant. So, nasa first quadrant siya because yung nasa first quadrant siya because yung sigma ay yung component x and component y natin is both positive.
Good day. I am Claire Shua and I will be discuss about the two example of the non-concurrent forces. This is the example of resultant of force system of non-concurrent force system. So, sa problem na to, determine the resultant of the non-concurrent force system. So, yung formula ng resultant is square root of the summation of force vertical squared plus summation of force resultant squared. Parehas lang to dun sa summation of Fy plus Fx squared nung previous semester natin. Iba lang yung ginamit ko. So, summation of F vertical is equals to negative 40 minus 30 sine 75 plus 50 times 3/5. So, summation of force vertical is equals to negative 38.98 kilonewton. So, ano siya? Negative. So, pag negative, means downward. Then, summation of force resultant is equals to 50 times 4/5 plus 30 cos 75. And summation of force resultant is equals to 47.76 kilonewton. So, positive siya. Kaya, right. Then, resultant is equals to square root of 47.75 squared plus 38.98 squared is equals to 61.64 kilonewton. So, sinama ko na rin yung summation of movement at origin. So, is equals to 40 times 3 plus 50 times 3/5 times 2.5 plus 30 cos 75 times 2.5. Movement of the origin is equals to 214.41 kilonewton meter. Then, last, theta x is equals to tan negative 1 is equals to fy divided by fx. Tan negative 1, negative 38.98 divided by 47.75 is equals to negative 39.22 degree. Problem 2. In a certain non-concurrent force system, it is found that summation of fx is equals to negative 80 pounds and summation of fy is equals to 160 pounds and summation of movement at origin is equals to 480 pounds-feet. In a counterclockwise sense, determine the point at which the resultant intersects the y-axis. So, dyan yung given natin. Summation of fx is equals to negative 80 pounds and summation of fy is equals to 160 pounds and summation of mo is equals to 480 pounds-feet. So, ito yung formula. So, movement of the origin is equals to 480 pounds-feet is equals to summation of fx. Yan, summation of x is equals to 480. So, i-divide lang siya both side by 80 para makuha yung b. b is equals to 6 feet. So, the y-intercept of the resultant is 6 feet above the origin.
Concurrent force system. Example, determine completely the resultant of the forces acting on this step population in figure. So, ito ang ating figure. Ang una natin gagawin is sum ng x and sum ng y. So, para makuha natin yon, summation f of x equals to 750 sine 60 degree plus 250 lb. So, kapag pinag-add natin itong dalawa, ang kakalabasan niya is 899.52 lb to the right. Ang next naman natin kukunin ay summation f of y. Summation f of y equals to 750 cos 60 degree. Bakit siya 1,250 negative? Kasi pa left side siya. So, kaya siya magiging negative. So, kapag sinolve natin itong dalawa, ang kakalabasan niya is 875 lb downward. Ang next naman natin kukunin is resultant. Resultant equals to, ito yung equation niya. Resultant equals to square root of r of x squared plus r of y squared. So, ang next natin gagawin is ilalagay natin yung nakuha natin sagot sa r of x and r of y. So, kapag pinag-solve natin itong dalawa, ang kakalabasan ng resultant is 1,254.89 lb. So, ang next naman natin kukunin is tan. Tan delta equals to r of y over r of x. So, tan delta equals to 875 over 899.52. Pag sinolve natin itong dalawa, ang kakalabasan niya is 44.21 degree. Example number 2. The effect of a certain non-concurrent force system is defined by the following data. Summation f of x equals to 90 kN, summation f of y negative 60 kN, and summation f of o 360 kN times m. Counterclockwise. Determine the point at which the resultant intersects x-axis. So, yung given natin is summation of f of x 90 kN. Summation f of y is equals to negative 60 kN. Summation of m of o 360 kN times n. Ang required na hinahanap natin is x-axis. Ang solution natin, MO equals to 360 kN times n. So, para makuha natin yung x-axis, ang gagamitin natin given is yung summation f of y is negative 60. I-divide natin siya sa 360. So, kapag dinivide natin yung 360 sa 60 kN, ang kakalabasan niya is 6 meters. The answer is 6 meters. The x-intercept is at 6 meters to the left of the origin.
Good day, I am Angelo A. Del Santos and I am about to discuss about how to find the resultant of a parallel force system. Okay, let's start. Let's take a look at the example number 1. As you can see in the figure, there are 4 forces applied in this system. Point A, B, C, and D. And 100 Newton was applied from point A, 120 Newton was applied from point B, 80 Newton was applied from point C, and 10 Newton was applied from point D. And there are 2 meter, 1 meter, and 2 meters as you can see in the figure, and that represents the distance or the D. Okay, so for our solution to find the resultant, but first, let's assume that let's assume that if the force was applied downwards, like the point A, then it is negative. But if the force was applied upwards, like point B and C, then it is positive. So to find the resultant is equals to summation of forces. Resultant is equals to negative 10 because point A was applied downwards, so it is negative. Because we assume that if the force was applied downwards, then it is negative, and vice versa. Negative 100 plus 120 plus 80 minus 10. So, to calculate that, we have found that resultant is equals to 90 Newton, and the direction of it is upwards because 90 Newton is positive. And to find the distance of the resultant, let us use the Bragdon's theory. And to find the distance of the resultant, R is times D is equals to B, or the force from point B times D, or the distance from point B to point A, plus the force from point C times the distance from point C to point A, minus the force from point D times the distance from point D to point A. So resultant is equals to 90 times D equals to 120 times 2 plus 80 times 3 minus 10 times 5. 90 times D divided by 90 equals to 430 divided by 90. Let's cancel out 90, so to find distance equals to 430 divided by 90. So to calculate that, distance is equals to 4.78 meters. Let's take a look at the distance of the resultant. As you can see in the figure or the PowerPoint, the distance of the resultant is 4.78 meters, and the resultant is equals to 90 Newton. For the second example, there are also 4 forces that was applied in the system, point A, B, C, and D. But this time, the force was vice versa. The force is different, and the direction of it is different also. From point A, 240 Newton was applied upwards. From point B, 200 Newton was applied downwards, and from point C, 110 Newton was applied downwards also, and from point D, 240 Newtons was applied upwards also. And 2.5, 1.5, and 2 meters to representing the distance. And now for the solution. Again, let us assume that if the force was applied upwards, then it is positive, and if the force was applied downwards, then it is negative. R is equals to summation of forces, which is equals to 240 because the force was applied upwards, so it is positive, minus 200 minus 100 plus 240. And to calculate that, we have found that resultant is equals to 170 Newton, and the direction of it is upwards because 170 is positive. And to find the distance of the resultant, let us use the Bragnon's theory, or to find the distance of the resultant, which is equals to the force from point B times the distance from point B to point A, plus the force from point C times the distance from point C to point A, minus the force from point D times the distance from point D to point A. So resultant 170 times D is equals to negative 200 times 2.5 minus 100 times 4 plus 240 times 6. And 170 times d divided by 170 is equals to 500 divided by 170. Let's cancel out 170 to find that distance, which is equals to 500 divided by 170. So to find the distance, we calculated that distance is equals to 2.94 meters. Let's take a look at the distance of the resultant. As you can see in the figure, the distance of the resultant is 2.94 meters and the resultant is equivalent to 170 newtons. That's all for my example. Thank you for listening.
When marimba rhythm starts.
Good day everyone, I'm here today to present an example problem about the resultant of a parallel force system. So problem 1, a parallel force system acts on a lever shown below. Determine the magnitude and the position of the resultant. So to solve this problem, we are going to use a formula right here. Number 1 is R, which is the resultant, equals the F, which is the force, times D, which is the distance, or the moment of arm of a certain force. We use this formula to solve for the magnitude and direction of the resultant. Next, we have number 2, the summation of moment equals the F, which is the force, times D, which is the distance. We use this formula to solve for the moment of parallel force. And all the parallel forces will multiply by its moment arm. And the number 3, we have summation of moment times R, which is the resultant, times D, which is the distance. We use this formula to solve for the position of resultant. Let's get started. So here we have a figure. It's overhung. We have supported from here, but from the end we don't have a support. So to solve, we're going to first find the magnitude of the resultant. Let's write R, which is the resultant, equals the summation of forces. So R is equals to these forces. Let's going to write it here. So first is 30. The arrow is downward, so means that it's negative. If the arrow is upward, the sign will be positive, so it's negative 30. Next, we have 60 right here. The arrow is downward, so it's negative. Next, we have 20. The arrow is upward, so it's positive. Let's write the positive 20. Next is downward 40, so it's negative 40. And if we write it in calculator, the answer will be negative 110. Don't forget the sign, the unit. Negative 100 pounds. The arrow is downward because the sign is negative. So now that we all know the magnitude of the resultant, but we don't know where it's lay from the beam, so let us find the moment of all the parallel forces from the given problem. So let's write the problem right here. The summation of moment A from here equals the force F times D. Let's assume that all the clockwise is positive right here, and the rotation of counterclockwise will be negative. Right, positive, negative. Okay. The summation of A is equals to the force 30 times its distance 2 is 2 inches. Next we have
60. It's positive because it's downward. It rotates clockwise. So, positive 60 times to its distance. We have here 3 plus 2. So, we got 5. Then, next is the force 20. The arrow is upward. So, it rotates counterclockwise like that. So, we have negative 20. And the distance will be 2 plus 3, 5. Plus 2 will be 7. So, we put the 7 right here. Next, we have 40. It's downward, so it rotates clockwise. The sign will be positive 40. And the distance will be this. 4 plus 2 is 6 plus 3 plus 9 plus 2 is 11. So, we write here 11. If we put it in a calculator, the answer will be 660 pounds inches. Since we are now determining our moment, let us take the location of the arm. We can determine it with the use of the formula number 3, which is the summation of A equals to the R, which is the resultant, times D, which is the distance. Let's just substitute the value that we already solved a while ago, which is the summation of A and the resultant. So, let's substitute. Let's write this 660 from the summation of A and equals to the 110, which is from the resultant. We're not going to write the sign, or let's not just consider the sign because the negative sign is only means that the force is going down and the positive sign is going upward. Then let's just write 110 times D. And if we're going to write it in a calculator, the answer will be D is equals to 6 inches. According to our answer, we have the resultant of negative 10 pounds that have a distance of 6 inches from the support. So, the resultant will be located here, 110, negative 110, and the distance will be located here from the moment A. And that's our answer for the problem 1. Here is another example problem of the resultant of parallel force system. We will solve this as same as the number 1 problem. We will just determine the magnitude and the position of the resultant. So, based on the figure here, we have two support, the ruler and the hinge. We have the 1 point load from here going down, and we also have the uniform load that is 10 kilonewtons per meter. So from this problem example, we will going to use the kilonewtons and meter as the unit. First thing first, we will going to solve the resultant. R equals the summation of these forces. So R is equals to negative 5 because the arrow here is going down, so it means it's negative, and then negative 10 because the arrow is also going down, but you will be multiplying its distance here. So 10 times 3 meters. We will be multiplying all the whole force. So 10 is measured as 3 meters. So we will be writing the negative 10 times 3. If we calculate it, the answer will be negative 35 kilonewtons per meter. Don't forget the unit. Next, we will going to solve for the moment. Same as the problem 1 that we solved a while ago, but now we will going to have a moment from B here, right here, at the hinge. Here we will be start from 5 kilonewtons. Wait, let me write the formula first. Negative 5 kilonewtons. As you can see, it's negative 5 because from here it rotates counterclockwise, means negative. So we assume that the rotation of counterclockwise will be negative and the clockwise will be positive. So it's negative 5 times its moment arm, or the distance from the force to the moment here. So it's 6. 3 plus 3, 6. Next is here, negative 10. It's negative 10 because the rotation is counterclockwise as well, times 3, or the distance of it. But it is still not the moment arm, because the moment arm of uniform load is the half of its distance. So here is 3 meters. The half of 3 meters is 1.5. 1.5 is the moment arm of 10 kilonewtons per meter. So if we calculate it, the answer will be negative 75 kilonewtons per meter. The last step will here we're going to find the distance of the resultant for us to locate the position of it from the beam. So the summation moment B is 75. We're not going to put the sign because we're just going to find the distance. The distance will not be negative though, so we're not going to write the negative sign. Next, the resultance is 35 times D. If we put it in the calculator, the answer that will appear is 2.14 meters. So it means our resultant, which is negative 35 kilonewtons per meter, will be going down
When marimba rhythm starts